Ooh, that's a good question. Anything in math, I'll give you time at the end of the hour. Besides this worksheet I gave you right now, everything else you can be recycled. But I think history, there is some stuff. Yeah. But otherwise, it'd be a good time to clean out your binders. I might encourage people to do that today during enrichment. So good call. Math, the only thing you have to keep is this chapter 3 thing. Okay? All right. Relationships that have straight line graphs are called linear. Notice it has the word line in it. Linear relationships. The rate of change between any 2 points in a linear relationship is the same, or we use the word constant. Constant means the same. It stays the same. So the phrase we're going to use over and over is that linear relationships has a constant rate of change. This sentence right here, or this phrase, constant rate of change. Constant rate of change. When we are finding the constant rate of change, here's something Miss Hoff is going to go crazy about. You always put y over x. Y is always on top. Y is always on top. So on the table at the right, we put the change in y over the change in x. Now notice on this table, they put y's on top. What is the change every time in our y's? Plus 2. So it says we put the change of 2 over the x change. What's the x change? 1. So our rate of change would be 2 over 1, or in other words, 2. Okay? Change in y over x. Y on top. Y on top. Okay? Is the relationship of temperature and time linear? If so, find the constant rate of change. If not, explain your reasoning. In a table, vertically, the left column is always x. The right column is always y. Write that down so you don't forget. The left column is always x. The right column is always y. So then we do swoops. What is my change if I go from 5 to 10? Plus or minus? Plus 5. And then from 10 to 15. Everybody should be writing this down. This is how you show me your work. And then 15 to 20. Plus 5. Nope. You have to be match it just like mine. Don't take a shortcut. Okay? Now, what is my change from 95 to 90? Minus 5. Nicely done. She noticed that it went down. So I'm going to put minus 5. How about from 90 to 86? Minus 4. And 86 to 82. Now, do you guys know how to type this into your calculator? If you want to find the change, you type the number below minus the number above. So on this one, you would type 90 minus 95. That's how we got a minus 5. 86 minus 90. That's how we got negative 4. 82 minus 86 gives me 82 minus 86. Guys, are you typing this in or are you guessing? Because if you're guessing, you're not helping yourself. You're not helping anybody around you. 82, Tone, minus 86 is negative 4. It's important that you know if it's negative or if it's positive. It's fine to use your calculator. So now we have to list our rates of change. Change in which letter goes on top? Y. Y, Y, Y. So our first change in Y is change in Y, negative 5. And the first change in X was positive 5. That's why I highlighted these the same. Now we go to the next group. What's the second change in Y? Negative 4. And the second change in X? Positive 5. And the third one, change in Y? Negative 4. change in x, positive 5. Now, we're trying to determine if this is linear. In order for it to be called linear, it has to have a constant rate of change. And constant means the same. Are those fractions all the same? No. So does this have a constant rate of change? No. Is this linear? No. Does it have a constant rate of change? Then it can't be linear. Linear is constant rate of change. So we would say, no, Miss Hoff will let you shortcut this. ROC, what do you think ROC stands for? Rate of change is not constant. It is not the same. It asks if it's linear. No, it's not linear because the rate of change is not constant. Do you have to have that explanation on there? Yes. If those fractions were all the same, constant means the same, then we could say yes. Okay, so the next one. Is the number of times and the volunteers linear? If so, find the constant rate of change. If not, explain your reasoning. This time they gave it to us on a graph. You know what the first thing I'm going to do? I'm going to make a table. Okay? I'm going to make an XY table right here. There's 3 points, so I know I'm going to need 3 spots for numbers. Don't shout. Everybody look. Who can tell me what this point's location is? X, comma, Y. Don't shout. Everyone look. I want to know the X, comma, Y location of that first point. Liana, what are you thinking? Perfect. That's exactly what I'm looking for. 8 was the X and 80 was the Y. Nicely done. Let's look at the next point. Don't shout, but raise your hand. Who can tell me the location of that yellow point? Petro? Look at your graph. There's something that will help you. Your X and Y are labeled, yes? So what's your X value? 16, and your Y value? 60. And who's got the last one for me? Marilyn. 24 and 40. Nicely done. Okay? All right, now we got to do the swoops. What is my change from 8 to 16? Plus 8. 16 to 24. Plus 8 again? Yes? Okay. Now go on the other side. 80 to 60. Okay, how do I figure this out? Don't guess, you guys. Don't guess. Take 60 minus 80. Negative 20. 60 to 40. Negative 20. Okay, the whole point of this is to see if we have a constant rate of change. Which letter goes on top? Y. Change in Y over change in X. What's my first change in Y? Negative 20. What's my first change in X? Positive 8. Second one. What's my second change in Y? And my second change in X? Are those the same? That means they are, and I heard somebody up here say it already. They're constant, right? Constant means the same. If we have a constant rate of change, what do you know? They're the same. What was the question they asked us? If it's linear. So we would say, yes. Yes, this is linear. Because the ROC, Ms. Hoff lets us use ROC, which stands for rate of change, is constant. You should be writing this down. At, Ms. Hoff will even let you use the at symbol, negative 20/8. You're telling me, yes, this forms a line because I have a constant rate of change, or in other words, the same rate of change, and then you're telling me it's negative 20/8. Linear means it's a line. Rate of change is constant. It's the same. Both of these are the same fraction. I want you to try the next one totally on your own. X is chairs, Y is paint. X is chairs, Y is paint. Determine if that is linear. Same exact process as you did right here. Everybody do it here. It's fine if you use your calculator. Pay attention if it's going up or down. The same thing down here. Show your change between your x's. How much does it go up or down? From 5 to 10. Does it go up or down? Okay, let me do the next thing. 10 to 15. Up 2? 6 to 12 is up 2? Never go by multiplication. 12 to 18. If you put minus 6, you're telling me it's going down to get here. Does it go down or does it go up? But don't add these two together. You got to find what do I have to add to 6 to get to 12? Take the bottom one minus the top one. What is my change from 5 to 10? And from 10 to 15? 6 to 12? Positive 6. 12 to 18? Positive 6. So what do my fractions look like? 6/5 and 6/5. Are those the same? What's that word we use? Constant. If they're constant, what do you know about chairs and paint? They are, what's the word we're looking for though? Linear. They asked us if they're linear. The amount of paint is shown. Is the relationship linear? So you would say, yes, linear, because the ROC is constant at 6/5. This is a real question, and some of you totally can do this. But to get the change, you take the bottom minus the top. So if you can't do that in your head, which is fine, you take 12 minus 6, which gives me a positive 6. You take 18 minus 12, which gives me a positive 6. If you don't have the right sign, you'll never get these correct. So it's fine to check in your calculator. You take the bottom minus the top, the one below minus the one above. Linear means I have to have a constant rate of change. Constant means the same. Rate of change, y on top. Y on top. Okay, flip it over. Proportional. This is something you learned in 7th grade that we're going to really quickly review. Proportional relationship says there's a constant ratio and a constant rate of change. Well, we just talked about a constant rate of change means it's a line. So my question is, if we're just looking at graphs, how do I know if it's proportional or not? Graphs that are proportional are a straight line. They are a straight line, and they go through the origin, or in other words, 0, 0. There's not even any calculating to do here, guys. You just have to look at the graph. Does it go through the origin, and is it a line? Then you would say, yes, it's proportional. So it says on the graphs below, write whether each is proportional or not. Explain your reasoning. First thing you check, is this a line?
Yeah.
Yes. Second thing you check, does it go through the origin? No, the origin would be down in that corner. So is this proportional? No, does not go through, you could say origin or 0, 0, means the same thing. Does not go through the origin. You have to explain why. Okay, second graph. What's the first thing I ask? Is it a line?
No.
Is this a line?
No.
What's a line? Doesn't matter. We're not talking about placement. Is it a line? Yes, this is a line. What? That's not curved.
No, I'm saying that line can't be.
Correct, correct. That one is not. Yes. He's saying a line is not a curve. Yes. Basically, could you lay your pencil on it and it matches your pencil?
Yeah.
The second thing is, does it go through the origin? Yes. So is this proportional? Yes. It is a line and goes through 0, 0. Yes, this is proportional. It goes through the origin and is a line. O-R-I-G-I-N. That says organ, like a piano. Do the last one on your own. Determine if that last one is proportional. Determine if that last one is proportional. O-R-I-G-I-N. Yes. Is this proportional?
No.
Why not?
It doesn't go to the origin.
Very good. It's a line, but it does not go through the origin. No, does not go through the origin. If you write out origin, make sure you spell it correctly. O-R-I-G-I-N. Not an organ in your body and not an organ like a piano. Origin. And all you're hoping is there's a lot of proportional problems on your homework, right? Because those are super simple. All right. One thing Miss Hoff forgot. She's not worried about it really. Okay. So your homework today says determine whether the relationship described is linear. Linear means constant rate of change. Constant means the same. So on every single one of these tables, I'm going to see you have arrows telling me the change. I know you don't have this worksheet yet. That's how I make sure you're listening to me. Okay? These are always X. The right is always Y. When they run horizontally, the top is always X. The bottom is always Y. Okay? And you'll be good there. All right? The rest of the hour, this is yours. The rest of the hour is yours to work. This is due at the start of class tomorrow. What else do you need to bring tomorrow? Your math book and a pencil would be also nice, but your math book too.